Okay, happy Friday, everybody. I'm actually at school today, so that's why the background is a little bit different and haven't got the headgear on. Bonus points from anyone who can guess which area of the school I'm filming this from. So if you do think you can locate me, that'll be prize up for grabs there. Okay, right. Today we're looking at carrying on with Vargan diagrams. This is going to get slightly harder, just to pre-warn you. So do take your time to watch this video carefully. What we're going to look at the loci of an argument. Okay, now loci is the all the points that satisfy a condition. Okay, now at this point I'm going to disappear, guys. So have a good weekend. Catch you again on Tuesday. But I hope you enjoy this one. Okay, loci in the Argon diagram. So now, if we're going to look at a circle, there's a couple of others we're going to look at, but we're going to look at a circle here. Now, what I mean by this is, so if I had the example, draw a locus of points 5 meters away from X, okay, and X, let's say if I put X there, the locus of points, all the possible points 5 meters away, well, that would form, hopefully you'd agree with this, a circle of 5 meters. So the locus of points is described as that circle, okay. Now, if we go back to AS level, so just recap, the equation of a circle is x minus x1 squared plus y minus y1 squared equals r squared. Okay, now this is the radius, it has a radius of r and a center of x1, y1. Okay, so that would be the circle there. Center x1, y1, and the radius of r. Now we're going to come back to that feature in a minute because I can describe this in the complex form. Okay, so if I was to find the equation of the locus of points, e.g. 3 units away from the point 2, 3, for example, find the equation of the locus points 3 units away from the point 2, 3. Well, that means it's going to be a circle with center 2, 3, radius 3. So my actual answer would be, okay, well, it's x minus 2 squared plus y minus 3 squared equals the radius squared. That would be my answer. Okay. Right, that's in the real mode. Now, it's sometimes useful to know what a locus of points is in the complex domain or the complex area. So if we look at the complex mode, complex area, the only difference is I plot it using on an Argon diagram. So let's draw an Argon diagram. Imaginary. Okay. Now at this point, I'm going to plot a complex number. Here, I'm going to call this point 5 plus 3i. Okay. Again, remember we can draw that as a vector. Now, so I'm going to call that point Z1. So Z1, and what I'm going to say is find the locus of points. Okay, the locus of points. Now, the locus of points Z, which is 3 units away from Z1. Okay. Now, so that means 3 units away. That's going to be 1 point, but again, all of these points, it's going to form a circle again. Okay, now what I want to do is try and find the equation of that circle. Now, if at this stage I go into GeoGebra, which is quite good, so I've got the point there, 5, 3. Okay, that B is at 5, 3. Z2 here, that length I've defined that as 3. And if we put a trace on this, again, all I'm going to do is, so as I draw this round, fixing it 3 meters, you'll see it draws a nice circle. Okay. So what I want to find out is this vector z. So what is that vector z? Obviously z varies as I go around the circle, but I need an equation really. What is that complex number c? Well, at c, what's that complex number z going to be? Okay. So if I go back into my sketch, so I've called this one z1. This point here, I'm just going to put any point, just a random point there, and I'm going to call that vector z. That's the z vector of interest. Okay. Now, just to help me work this out, that vector there. Now, to get from let's call that A and that B. To get from A to B, I need to go minus the z1 vector plus the z vector. Okay, as I go down, down, backwards down z1, and then forwards on z. Or AB must equal z minus z1. If I just repeat that, just do it in a different way. Okay. Now, what I've already defined that that length there, that length AB, is equal to 3 units. Okay. So I know AB. The modulus of A to B is equal to 3. The length is 3, or Z minus Z1. The modulus of that is also 3. Okay. Now, but Z1 is fixed, you will have seen. So Z1 is fixed. So I know that's the center, isn't it, of my circle. So Z minus Z1. Now, Z1 was that is 5 plus 3i. 5 plus 3i. The modulus of that must equal 3. Okay, now that is as far as I need to go. That there is effectively the equation of a circle in the Argand diagram. Okay, so that's the equation of a circle in the Argand diagram. And it's got a center of 5 plus 3i and a radius of 3. Okay. Now, I could actually, at this point, I could even go back to the Cartesian form. Okay, so I could go back to the Cartesian form. That's the complex form. Now, if I was to convert this to Cartesian, well, I know the modulus of a complex number. Now, remember, if z is a complex number, let's call a different complex number x3 plus iy3. The modulus, remember, the length of that line is going to equal the square root of x3 squared plus y3 squared. We've done that already. Or z3 squared, the modulus of that squared is going to equal z3 squared plus y squared. Okay. So if I go back to my example then, if I let z just aside, if I let z equal x plus yi, I'm going to end up with x plus yi minus 5 plus 3i. The modulus of that must equal 3. Okay, now if I keep going on this, if I group the real bits together, I get x minus 5. I'm going to get plus y minus 3i. All I've done is just reordered that and factorized it, equals 3. And remember, the modulus is going to be, so it's x plus 5 squared plus y minus 3 squared equals 3 squared, which is 9. And that is the Cartesian equation, which works, doesn't it? Because the centre's 5, 3 and the radius is 9, which is quite nice. Centre 5, 3, radius of 3, square root of 9, sorry. Okay, so that's how you flick between the complex mode and the Cartesian. We'll look at an example of that in a minute. Now, you don't need to know the proof of that, but you need to know in general. So if you've got z minus z1 in that form equals r, this will form a circle in the Argand diagram with center z1 and radius r. Okay, that is, you weren't sort of following up to that point, that is the key information you need for this exercise. Okay, I'm going to do a few examples now. So I'm going to go straight example from, this is all from the book. I'm going to look at example number 11 first, which is on page 29. And it says, here's the question. It says z minus 4, the modulus of that equals 5. That's a given, okay? Part 1, sketch the locus of points. The locus of points z on an Argand diagram. Okay, and just maybe pause the video at this point to have a go at that. Okay, now I can go straight in and I know the radius immediately is 5, which is useful because it's that, and I know the centre is going to be negative that, well, it's going to be whatever's in there. So the centre is going to be 4 plus 0i. There's no I coefficient there. There's 0. From that point onwards, I can plot that quite easily. Centre is 4 here. That's going to be just 4. There's no imaginary part to that. And the radius is 5, so I'm just going to, that's where it's going to go through. And it's going to look something like that. A terrible sketch, but that's roughly what it will look like. It's good enough. Okay, that's part 1. Part 2, find the values of z that satisfy both. So what satisfies both this equation, so that equation is the whole circle, and the imaginary part of z equaling 0. Okay, so where does the imaginary part of z equal 0 on that circle? Well, it's going to be here and here. Okay, that's where the imaginary part is 0. So that point there is going to be, well, the radius is 5, remember, so the answer here is just going to be -1, and the other side is going to be 9. Okay, so you've got z equals -1 or z equals 9. That's the sort of solution to that part of the equation. Right, number 3. Another one, so what satisfies both that, so the circle, and the real part of z being 0? Okay, well this one here, that's going to be the real part equal 0, it's going to cross there and there. Okay, so what we need to do there, we need to find out those coordinates. Okay. Now, best way to do this quite often is to work out the Cartesian equation. Okay, so Cartesian equation, sometimes like these blue ones, it's very easy to get using symmetry. This is a little bit harder to find. I do know that x is equal to 0 though, if I found the Cartesian equation. The Cartesian equation is super easy to get because I know the centre is just 4, 0. I know the centre is 4, 0, and I know the radius is 5. So I know straight away the Cartesian equation is x minus 4 squared plus y minus 0. squared equals 5 squared. If the real is 0, that means that x is 0. So when x equals 0, we end up with a situation, so 16, because minus 4 squared, plus y squared equals 25. If I solve that equation, I end up with y equaling 3. Okay? So my answer, if y or minus 3, it's 3 or minus 3. So my actual answer, z in this case, is going to be 3i or negative 3i. Okay? And that's how I'd answer that sort of question there. Okay, that's example number 11. I'm going to do a couple more because this is a tricky-ish topic. Example number 12. Okay. I've got a different locus of points there. Minus 5 minus 3i equals 3. Okay, sketch the locus. Sketch locus of z. B, find the Cartesian equation. And C, which we'll come on to in a minute, is find the minimum value, min value of the arg of this z. Okay. Right, sketch the locus. Now I know, let's start with A. I know the radius is 3. Okay, that's going to be helpful straight away. And I've just got to be a little bit careful. It's not in exactly the form I want it in. I want it z minus something equals 3. Okay. Now, if I do z minus something, just be really careful. That's got to be a 5, but then this is going to switch to a plus 3i. Okay, so be really careful that you get it in that form. Okay, got to be in that form. So I now know the center is going to be 5 plus 3i. So on the Argand diagram here, imaginary, real, 5, 3, so it's going to be like that, and it's going to have a circle radius 3. It will actually going to go back. Okay, so that's going to be the sketch on the on the Argand diagram. Sketch the locus. Find the Cartesian equation. That's so easy to get. Now once you've sketched it, it's simply x minus 5 squared plus y minus 3 squared equals 3 squared, which is 9. Okay, then it says find the minimum value of the argument of z. Okay, in the interval minus pi, so between minus pi and pi. Okay, so between so the maximum value, because the minimum value is obviously going to be there, so it'll be 0. Maximum value. Now, where on this circle, I'm going to actually redraw this because I'm going to redraw this. So the maximum value of z, the maximum value of the argument is definitely going to be when this here is the tangent. If that's the tangent, we're going to get a bit of a mess there. That has got to be 90 degrees. That is definitely going to be the point where that angle is its biggest. That's the maximum I want there. So I really do want to work out what that value is. And this is a 90-degree angle because of equation of tangent to a radius. I know the radius is 3. Let's stick that on there. Okay. Now, I also know, this is a bit of manipulation of geometry now, I also know that's going to be 3, okay? I also know that length there is 5. Now, because what I've created here, I've got two tangents. I've got a tangent there and a tangent there, which means if I split this down the middle, that is going to be half of theta, okay? So I know theta over 2 is going to equal, again, 3 and 5. It's going to be the inverse tan of 3/5. Okay. Now, so theta ends up being twice the inverse tan 3/5. And the actual answer to that turns out to be 1.08 radians, okay? So that is how you find the maximum. The minimum argument of z would have been 0 there, because it's... Right, okay. Final example. So example 13. So I've got z is equal to x plus iy. And it satisfies the equation again, z minus 12 minus 5i, the modulus of that all equals 3 again. And it says find the minimum value of the modulus of z. Okay, so the minimum length that could be, and the maximum z. Okay, so again, maybe pause the video, have a go at this yourself. Best thing to do here is to sketch it out again. In fact, you have to sketch it out. But I need to be careful I rearrange this to get it in the correct form first. So it's going to be minus 12 there, but then a plus 5i equals 3. Okay, so I can go straight away and draw this in. 12, 5 is going to be up here. That's the center, and the radius is 3, so it's going to look something like that with a radius of 3. Okay, now the minimum value of z will be when this point here, if I draw a line going all the way through, okay, this is that point there, this distance is going to be the minimum value of z. So, okay, when that just hits the circle there, okay? And the maximum will be this point here. That's the furthest away that could possibly be, isn't it? Okay. Right, now I also remember that is C, and that's a length of 3. Let me just rub this off to it's a bit clearer. And that's also a length of 3. Okay. Right, now, I know what I can do here is I can split this some quite nice. I know the distance from O to the center. Okay, so I know the distance from O to the center. That's just Pythagoras. It's 12 squared plus 5 squared rooted. So O to C, the distance from O to the center is going to be, that's quite a nice value, that's 13. So that whole distance there is 13. Therefore, the minimum value of z, well, it's quite simply just 13 minus a radius, minus 3. So the minimum value would be 10. The maximum possible distance from the origin to z will be the other side of the circle, so it'll be 13 plus 3, which is 16. So that's the biggest that distance could be. Okay. All of this does have applications, actually, you'll be surprised, but working out the specific distances from a point is very useful in complex mode. So it's really important to know how to do it. Okay, that's it for the examples today. Take your time on this session, it's not easy. But we're just going to do circles. I want you to now do page 34, exercise 2E, questions 1 to 5. Okay. And I do want you to finish for homework. Okay, next lesson we're going to look at perpendicular lines. But circles, once you do the questions, you'll find that they're not too bad. Okay, so you should find they're okay.